Okay, so we start with parallelograms and triangles. We have two different approaches to talking about the area of these two things because they're very much related. You can start with parallelograms and get triangles, or you can start with triangles and get parallelograms. I'm going to start with parallelograms and get triangles. So Faith, that is a parallelogram. Can you refresh our memories as to what a parallelogram is and what makes a parallelogram, and what's true about it, and anything else that we might need to know for this yellow figure up here?
Okay, two pairs of parallel sides.
Hence the name.
I know this.
I know you do, so I called on you.
Okay. Just by that picture, can I list anything?
Whatever you know about a parallelogram, share with us.
Opposite angles are congruent.
Good. That's equal to that. That's equal to that. Good.
It adds up to 360.
All the angles add up to 360 because it's quadrilateral. Good. Nothing else? Really?
I probably know it, but I can't.
Yeah, you do. As soon as Alyssa starts telling us, you're gonna be like, oh, yeah. Oh. Oh. At least 3 times you'll do that. Go ahead.
Adjacent angles are supplementary.
Yeah. That's all you got?
I just wanted to say one thing.
Oh, all right. Anybody else? Yes, Leo?
The opposite sides are equal.
No. Anything else? Yes?
Are the diagonals equal, or do they bisect each other?
Hold on. Do the diagonals bisect each other? Are they equal, or both, or neither? The 4 possibilities there.
They bisect each other.
They bisect each other, but they're not necessarily congruent, or they are congruent?
They're not. They're
They're
not
not.
necessarily.
No.
They're not congruent?
No, they are not.
No, they are not. Good. Anything else? I think we pretty much got most of it. We're concerned about 2 things. One is the base, and these are bases. The base isn't always the side that it's sitting on. That gets a little confusing. You want to think, well, the base is like, this part, the horizontal part at the bottom of the figure. That's not always the case. And in fact, we can measure a parallelogram differently by considering this the base. And then the other thing is the height. And the height is illustrated in the picture with that little red segment. However, that height does not have to be measured there. Remember, as Faith told us, these sides are parallel. And what's true about parallel lines?
They don't intersect.
They don't intersect. What else is true about parallel lines? I'm sorry?
They're perpendicular.
Parallel lines can't be perpendicular. Then they would be perpendicular.
No, never mind.
Right, these are perpendicular.
Yeah.
We'll get back to you in a second. But what else is true about parallel lines? Which is kind of important if you're on a train. Listen.
They don't intersect.
Good. He said that already. What else? Always same distance apart. Okay. Again, if that wasn't true on a train, you'd have a mess on your hands. So this height can be measured here. This height can be measured here. This height can be measured here. It can be measured over here. It doesn't matter. I just happened to draw it in that spot there. Those are the 2 things we need for a parallelogram. How long is the base, and how long is the height? And then, yes?
Could it be measured from the like the left segment to this right segment? The height, if you're saying it could be measured from anywhere?
I'm not sure if I understand what you're saying. You want to come up and draw?
Yeah.
Okay.
So like from here to there, I guess. I mean, that wouldn't be the height, obviously, but you said you could measure it anywhere. Could it be measured from there to there?
No, you can measure anywhere between the parallel lines.
Okay.
So it's got to be between this line and this line.
Okay.
So I could take something like this and extend it out over here. That would be a height. I could come over here and drop a height over here,
Right.
or come over here, extend the lines, and measure the height over here.
Okay.
Now, there is another height that we could measure, which would be something bizarre, like maybe like that. If we considered this the base. Obviously, we're still having technology issues here. That is the base. which would mean it would be something like that. But in general, we're going to use that as the base and that as the height.
Will it tell you?
Say again?
Will it tell you which one's the base?
Sometimes you're going to have to figure out which one is the base and go from there. Okay, so yeah. I got that. No. You guys find my screw ups hilarious, don't you? There we go. Okay, beautiful. Before we actually talk about the formula for the area of a trapezoid, we've got this little idea here, which we're going to use a lot. And even though it says the area addition postulate, you consider it the area addition / subtraction postulate. We're going to be finding if we just did the area of parallelograms, triangles, circles, squares, rectangles over and over again, it would be boring. We want to be able to calculate the area of some different shaped figures, which we might not have the formula for. So the area addition / subtraction postulate allows us to do it by taking any shape and break it into shapes that we can find the area of. So for instance, if I want to find the area of that mailbox / elephant looking thing, how would you do it? Nathan?
So for that curved bit, you would cut that into a semicircle,
Uh-huh.
and then you have two little squares at the bottom, and then what's left is the rectangle.
So you would come across here,
Yep.
come across here,
Little square.
and come across those little, we assume them to be squares, they look like squares. Find the area of the semicircle, the rectangle, and the two squares. Okay, beautiful. Anybody else? Any other ideas? Okay, one of the other ways that you could do it would be to extend this, find the area of this whole rectangle, and then subtract the area of that guy inside. Okay, so that would be an example of the subtraction property. Most people, however, I don't know if it's because that's the way our brains are wired, but most people will automatically go to finding the area of things that they can see, not the area of things they can't, if that makes sense. You could also split it vertically, for instance. You could have done this. Okay, so two rectangles and a square looking thing in the middle. You got a lot of options there. I mean, you can do all kinds of crazy, silly things. You know, this is pretty straightforward. You got to do the semicircle thing, but you could drop this down here, extend this across. Then you got two trapezoids, a square and a semicircle, okay, which would be kind of silly, but it is a possibility and still illustrates the idea of what we're talking about. Okay, so area of parallelogram, base times height. The case of the letters, uppercase and lowercase, becomes important now. So area, we use a capital A. The base and the height are lowercase letters. There's a reason for that that will become apparent later on when we get into volume. Gesundheit. So pretty simple formula, right? All right. So use that information to find the perimeter and the area of that gray looking parallelogram, please. And you will need your calculators, by the way. There are a couple different ways to solve this problem too, so we'll see what people do and what technique they use. this is my fault. I forgot to clarify. There's a couple things that you need to realize that aren't illustrated in the problem. That's perpendicular, and the gray thing is a parallelogram. Nowhere in the problem does it say it's a parallelogram. That's my fault. Question? All right, Olivia, let's do the easy one first. What's the perimeter?
104 inches.
How do we feel about that?
Yep.
Yep, good job with the units also, 104 inches. How'd you get that?
Well, since you know that the opposite parallel sides are congruent, then you have 20 plus 20 plus 32 plus 32.
Good, well done. All right, how about the area?
I got 512. I don't know if that's right.
How do we feel about that? Not as solid as an encouragement there. Some people didn't get it or have a different answer. Or lost the ability to speak. Okay, obviously it's losing the ability to speak. Ooh, look at that fancy 5. 512 what? What are your units? Inches squared. Or square inches, depending on whether you want to do that, or you could do squa in. Either one. All right, where'd you get that 512?
I used Pythagorean theorem to find the height. So
Okay, so we'll call that h.
I did 12 squared plus h squared equals 20 squared. And then
Whoa.
and
We'll
then,
just pretend that didn't happen. So h is,
h equals 16. And then the base is 32, so I did 32 times 16.
okay, start with a blank formula. Area equals base times height. As we get more and more figures that we're calculating the area for, you're going to get more and more formulas. As the grader, I want to know what formula did you use to start this problem so that if you did make a mistake, I can track your mistakes. You said the base is,
32.
and the height you just found to be 16, which gives us that 512 inches squared.
And so we have to write the area formula,
Every time.
the blank one?
Yes, sir. Yes, sir.
We should take points off if we didn't add the squared bit at the end, like 512 inches.
Yes, different units. Inches is a linear measurement. Anything you can measure with a ruler, inches squared is area units.
Okay.
So there is a difference. Any questions on this before we move on? We're good? Okay. Find the area of that guy. Same rules apply. It is a parallelogram, and that is perpendicular. I'm getting sloppy here. While you're calculating, who went the farthest away over spring break? Anybody leave the country? Where'd you go?
Montreal and Quebec City.
I guess you probably win then if no one else left the country.
Melissa went
Well,
to-
not necessarily,
Yeah,
because
Melissa
you
went-
could stay in the US and have traveled further than Quebec. So where did anybody else go? Florida?
Florida.
Florida? Florida, Florida, Florida? Cali, you said? Where?
San Francisco.
Oh, nice. Did you leave your heart there? Never mind. You young kids these days just don't appreciate it. There's an old song, I Left My Heart in San Francisco. Yeah, it loses so much in the translation. So California, San Francisco might be further away than Quebec. No, just go up.
Go off and to the right.
A little bit to the right, yeah, but still pretty much up.
Yeah.
San Francisco, just go,
Go.
go. You hear a splash, you went too
Yeah,
far.
until you hear gold, or you see, not you hear gold.
Until you hear gold?
Yeah. until
What do you have,
see
synesthesia?
gold.
Anybody familiar with that? Synesthesia?
Like where you like
Was that something
colors
on
and
our
stuff?
Wikipedia race?
It might have been, yeah. It's a condition where you, your senses are reversed. So you hear colors, you see smells. Very
There's
weird.
another word for that, just drugs.
I'm sorry, what?
No.
Okay. Anybody got an answer? What is that?
Okay.
You just give me the finger?
No,
Yes, you did.
no.
You totally did. You still working? What piece of information are we missing?
The height.
The height. How are we gonna find the height?
Well, it's a 45, 45, 90 triangle.
Uh-huh.
So the height's 9 over square root of 2.
Okay, so we know that's 9 because it's a
Right.
parallelogram, and so you did a square root of 2 is equal to 9. So a is equal to 9 divided by the square root of 2. My 9s and a's look the same. Okay, I like that so far. Anybody use trig, by the way?
Wait.
What am I waiting for?
No.
You gonna do something
Go ahead,
spectacular?
please.
Okay. Nobody use trig? Okay, that's fine. If you use trig, it's okay. In a problem like this where it didn't specify exact or approximate, trig is all right, but if it's an exact answer, you're going to have to use this method. All right. Area is base times height. What's the base, Faith?
12.
What's the height?
9 over square root of 2.
And when I multiply that out, I get?
108 over square root of 2.
Good. Which again, we don't care about rationalizing denominators, so you can leave it like that. What are my units?
Just units, right?
Close.
Something squared.
Correct.
Wasn't she right before unit squared?
She didn't say unit squared, she just said
Oh,
units.
okay, unit squared.
Unit squared. When you're not given units, then the units become the word units. And again, if you didn't, this problem doesn't specify, so if you could have converted this to a decimal and stored it, or you could have done the sign, oh, the blue looks cool on the black. The sign of 45 is equal to what? H over 9. And go ahead and solve that for H. You would get 6 something? 5 something? What is it?
6.36.
6.36. Anybody do this differently? Anybody do this? No? Okay, good. That's fine. You could, though. What shape is this?
Rectangle.
Could be a square, we don't know. You can solve this distance. Whoops. Solve that distance. Subtract to find that distance from 12. The numbers get ugly, but it's doable. We haven't really done the area of a triangle yet. It's coming up, but you all know the area of a triangle. That's why we're not going to beat a dead horse here. So another option. Now we get to triangles. So like I said at the beginning, we can start with parallelograms and get triangles. Any parallelogram, when you draw in one of the diagonals, splits it into 2 congruent triangles. So this triangle came from a parallelogram that extended out like this and like that. So there's the original parallelogram. You draw in one of the diagonals, and it divides it into 2 triangles, 2 congruent triangles. Therefore, if the area of the parallelogram is base times height, what's the area of the triangle? Base times height times a half, or base times height divided by 2. Pretty straightforward. But again, we knew that already, so we don't have to. Do I need to talk about this? Read quickly so we can move on. Does that make sense?
Yeah.
Good. All right, there you go. There's the official formula. 1/2 base times height, or base times height over 2. I don't care which one you want to use. If you're feeling saucy, you could even do 0.5 times base times height. And notice this is kind of funky the way I drew it on this triangle. However, I could do it differently by making this the base and this the height. And there's even a third way to do it. That's what's going to get kind of wonky when we start calculating area. There's different ways to calculate the area for the same figure. Okay, find the area of the gold triangle only. The dotted triangle is there to help you. you can go with an approximate answer on this, it'll make it a lot easier. But remember, even though you're doing approximate, you still want to store values.
What was
What was what?
that?
Paper? Paper off your desk?
What was that?
It was a piece of paper that was on the, nothing, it was a little schmutz. Just wanted to make sure it didn't end up on the floor. Fiona, how do we find H?
Oh, path vector 3.
Good, set it up for me.
13 squared equals 6 squared plus h squared.
Good, and what's H turn out to be?
I rounded it to 11.5.
And I'm assuming you stored that number, right? Okay, or if you wanted to stay exact, the square root of 133. Okay. You'll see in a second why storing or taking the exact answer doesn't matter in this case, but if you take the approximate answer, it's going to cause some problems. Okay, area of a triangle. 1/2 base times height. Fiona, what's the base?
29.
Good. And the height you already told me. Did you go with 11.5 or square root of 133?
I went with 11.5.
Which again you stored, right?
Oh, I did it.
Okay. But you should have. And when you're done, you get what for an answer?
167.
Yeah, 167.22.
0.22?
Yeah.
What? Centimeters squared. Not bad. Now to find the perimeter, because it does say to find the perimeter, how do I find that distance? Raj?
Do 29 squared plus 11 point, well, store value 11.5 squared equals
29 squared plus the stored value of 11.5 squared equals, let's call that x squared. Or 29 squared plus the square root of 133 squared equals x squared. If you use the stored value and square it, you're fine, because if you pull up that squared value and square it on your calculator, you'll get back to 133. If you use the approximate value, you're okay, because what's the square root of 133 squared? 133. However, if you use 11.5, George, what's 11.5 squared?
Oh. It is 132.25.
Not 133. Okay. So store it or use the exact value. What does x turn out to be?
71.74.
No.
Oh, x?
Yeah.
Oh, I'm sorry. Wait, yeah, wait.
No.
31.2.
31.21.
And then when you add the three sides together, you
Yeah.
get, what'd you say, 71 point?
71.74.
Okay, 31.2 plus 29 plus 11.5 gives us the perimeter of that triangle then. All right, I think this is our last one. I would suggest you start by drawing a picture, label the sides that you know. You're gonna have to pick a variable first. X is a good one to pick. let's start knocking this out. Kaylin, what'd you call the base?
X.
Okay, so this is x.
Yeah.
What's the height?
X plus 7.
Good. And it's a triangle. That what you did? Good. Multiplied it out. Did you, oh, what is this equal to, by the way?
Wait.
What is this equal to?
Area? Wait.
Yeah, it's the area, which is?
The number?
Yeah.
I didn't get the number. Oh, 60.
Okay, good. There you go. Now, when you solve this, did you distribute the 1/2 x to everything, or did you multiply everything by 2? Okay. What did the rest of you do? So you don't like the fraction. You can do either one, especially since you have a quad program on your calculator. It can handle anything. But I agree with you that I would multiply everything by 2 to get this. Then distribute. 0 is equal to x squared plus 7x minus 120. I think that factors, doesn't it? Well, regardless, what is x? Or
Negative 15.
-15. Which the -15 doesn't work. Why?
No negative signs.
Right. And again, for the gabillionth time, it's not, the negative answer doesn't work because it's a negative answer. It doesn't work because when you put it back into the problem, it gives you a negative distance. In geometry, we can't have that. Okay, so then we know x is 8, we know the height is 15, and we are done. If you didn't want to multiply out multiply everything by 2, then you would have gotten a quadratic that says 1/2 x squared plus 7/2 x minus 60. Plug that into your quadratic formula, you get the same results. That one's a little harder to factor, but with the technology, it makes it pretty easy to solve. So, entirely up to you how you want to solve it. It doesn't matter. We good on this? Can I erase it? Okay. Last one. I lied. This is the last one. For some odd reason, we're making a triangular sandbox. Who has a triangular sandbox? Nobody. They're either rectangular, square, or turtle shaped.
Yes.
Anybody have the turtle sandbox?
Used to.
Yeah. You don't still have it?
No.
Oh, bummer.
Grew out of it.
Yeah, you probably wouldn't fit in it now.
Yeah.
And you always forget to put the lid on, so that fills with water and just becomes like a slop pond. Mosquito haven. Kills a piece of grass in the shape of a turtle in your backyard.
Oh my god, yes.
Yeah. All those little type things just kill the grass, and like we had the turtle sandbox, we had the house.
We had a
the
mini
little-
playground as well.
Oh yeah? We
Yeah.
didn't have the mini playground. We had the house and the turtle sandbox. The little swinging door on the house. That's awesome. Probably had a homeless guy living in it at some point. Got rid of it. 2 ways to solve this problem. One considerably easier than the other, but I'll let you go for a little bit and see how you do it. Let's start with the easy part. Let's start with the easy part there. Johnny, how many boards do I need?
Alright, I understand.
Oh, did you just go to your happy place there for a while then?
I'm lost there.
Uh-huh.
Oh, wait, this is easy.
I'm sorry?
I have the answer.
Share.
Yeah. So, you just add 16, 7.5, and 12, and divide that by 3,
Okay.
and, that is, 11.83 repeating, which is the,
So am I gonna go into Home Depot and ask some big burly bearded Home Depot worker in his cool orange apron? Yo, Holmes, hook me up with 11.83 repeating
12
boards.
boards.
Okay, 12 boards, good.
Yeah.
Alright. Did you get the answer for the area yet?
No.
No. Jocelyn, what do you got for the area?
I don't have it yet.
What'd you start doing?
Well, I was gonna do the Pythagorean theorem
Okay.
to find the
To solve for this guy right here?
yeah.
Okay.
the little-
That little guy? Let's call it x. So you're gonna do x squared plus 6 squared equals 7.5 squared?
Yeah.
I'll save you some hassles to let you know that that's 4.5.
All right. So then I was gonna find the area of the triangle.
Which triangle? There's 3 of them up there.
The one with the x.
The area of this triangle?
Yeah.
Okay. That would be 1/2 base times height, which is 1/2 times 4.5 times 6, which would be 13.5, I think. Yes? Little help, somebody? Is that right? 6 times 4.5 times 1/2?
What triangle are we trying to find?
We just found the area of the red triangle.
Why don't we just do it?
Shh.
Well, why aren't
If I want your opinion, I'll give it to you. Mr. I love my brain. What?
Why don't we try and find the triangle?
She's getting there. Relax. Back to you.
Okay, so that's the area of this bone. Oh, so then I would do 12 plus 4.5 to find the. Alright, and then
Professional.
and then so the area of the triangle would be
Which triangle? The big one, the yellow one, or the
Sorry.
small one? The big one?
Yeah, the big one would be
Two, 49.5? Uh-huh. Back to you.
and then
You did the hard part. How do I get the area of the of this guy now? Hurry.
I don't know.
Nathan.
What do you have to do? 49.5 minus 13.5.
Beautiful.
You get 36.
Big triangle minus little triangle leaves you yellow triangle.
Okay.
49. Hold on. Feet squared? Okay. That's a pretty big sandbox, by the way. All right, now that we're all done with that, is there anything wrong with this method? No. Rock solid math. Got it all worked out. Okay? Good? Yep.
Isn't that big triangle not even possible?
What do you mean?
Because one of the legs is 16.5 and the hypotenuse is 16.
Hypotenuse.
Yeah. Well, the big triangle.
Yeah.
Oh, yeah. I didn't even notice that. That's crazy. I'll have to slap the person that wrote this problem.
Where was it?
What were you going to say?
I was gonna say, couldn't you just solve it like without trying to solve for the little one and for the big one? Since you already know the height is 6, couldn't you just done 1/2 times 6 times 12, and you'd still get the same answer, 36? So you didn't have to solve for the little one and the really big one as well.
Is there anything wrong with the way we solved it?
You could have.
Is there anything wrong with it?
No.
Okay then. Is this better?
Yes.
Why?
Because it's shorter.
This has fewer colors though.
Do that.
The other one was more colorful.
But
You can always just change up your colors.
You could.
Yeah.
You'd like change every number with a different, like if you had one of those clicky pens with the 40 colors on it, and then
why don't you want to make it more difficult for yourself? 'Cause it makes a bigger chance of screwing up.
Who said the last way was difficult? I got it right. I had no trouble.
But this one's easier than the last one.
Easy is a relative term.
Quicker.
That's true.
It could. I would accept that it's
Simpler.
probably quicker, but I wouldn't accept that it's easier.
It requires less work.
Yeah.
Less
Just
chance for
simpler.
messing up.
I mean, if you just never make mistakes, then you don't have to worry about it.
Yeah.
Sorry.
Like if you create a triangle that can't exist. That's a bunny. Okay, any questions? Schoology has a new chapter in, a couple new folders in there, chapter 11. The assignment sheet is on the main page. And then you've got assignments, resources, everything is pretty much normal. So, like I said, that's about the extent of the longest lesson we'll see in this chapter. Everything else will be a little bit more nitty-gritty.